Thank you guys for listening today. I'm pretty sure my headset's working, so we're just going to keep going. Hopefully I run through this fast because it's Sunday morning and I want to get home and watch some football. So Unit 3, Notes 1, you made it past the midterm. Now we're going to switch gears. Today is all definitions, but it's about polynomials. And we'll talk about that as we get there. So, these are supposed to be over here. Yeah. Base, the number in a power that is being multiplied. Exponent, the number in a power that tells you how many times to multiply the base. Alright, so we gotta get good with exponents and bases. When we do logs and pre-calc, you'll need to understand why. We'll get rid of that thing. Alright, so the base is talking about the lower number. Exponent is 3. Usually, I think you guys usually we'll call this a power, right? 2 to the power of 3, something like that. This is what we want to look at, though. This is meaning for us to do what? Well, this is equal to 2 times 2 times 2. When people write 2 times 3, that drives me absolutely freaking crazy. It is not 6. It is 2 times 2 times 2. That would be equal to 8. But you can see this is the third time, this is the second time, and this is the first one that you got to write. So that's what we're talking about when we have bases and exponents. Term, a number variable or the product of a number and or variables. Terms are separated by addition and subtraction. I got some examples for you here too. Alright, so an example of that would be 3x squared. Okay, that's a term. Okay, another term would be 7ab. You might get some that might have 9xy squared. Okay, those are all examples of a term. Alright, so we're still just looking at polynomials. We're breaking it down really specifically so we all have the same vocab. That's why it's a bunch of notes writing today. We got to have the same vocab to be able to do this unit. I'm trying to click and drag. There we go. Alright, coefficient. The numerical factor of a term that has a variable. So let's talk about coefficients for a second. An example of a coefficient might be 7x, which is, this 7 is the coefficient. Okay, it's whatever's out in front of the variable x. Or, for example, there might be another one where it's 6xy squared. Yes, this 6 is the coefficients, the x and y are variables in that term. Degree of a term. So this is the exponent on the variable of the term. Here's what we're looking at. So if we have 6x squared, okay, this is what we're looking at, 2. We would say the degree is 2. Say we had 3x to the 4th, okay, the degree there is 4. We'll get a lot of practice with these, so don't worry about it. Just make sure you get written down, and we'll try and move forward. So here we go, constant. Constants are the easy one. A term that contains only a number. Constants have no variable parts. So your examples here would be your favorite numbers. My favorite number is 3. Justin's favorite number is 21. 2015. Alright, those are all examples of constants. Like terms. Like terms are something that I've used before. We should have these all pretty much figured out. But we're going to talk about it. So 7x and 6x are like terms. 8ab and 5ab are like terms. Okay. 3x and 6x squared, These are not like terms. They do not go together. You cannot combine them. However, something like 3x squared and 6x squared, those are like terms. So they have to be to the same degree. Okay, so these would be an example where these are the same degree. That's why they work, where this one doesn't. These are both to the degree of 1, so even though it's two variables, they're still like terms. Polynomial. Alright, and we probably could have started off with this. A set of terms separated by pluses and minuses, or addition and subtraction, whatever you're comfortable with. Let's look at this. This poly word means many. Okay, many. So that's just a bunch of terms put together. That's all it's talking about. More specifically, monomial. Oh, wow. Mono means one. I know that word. Okay. Binomial. Bi is like bike. So that's 2. Okay. Trinomial. Those are probably the most common that we'll have, especially moving forward in math, is 3. Tricycle. But binomial just means many, and that's the one we use to describe all of them. But those are just things that we should be able to pick up on. An example of a set of terms, I'm going to use this a bunch for the next, 4 examples. It's just this. 3x squared minus 6x minus 4. That's an example where you have 4 terms there, and they're all separated by addition and subtraction. So those are what we're starting to look at, those polynomials. Did I hit back or forward, or what did I do? Leading coefficient. I'm looking for a degree of a polynomial. Was I on that? Did I screw up? Degree of a polynomial? There it is. Sorry, guys. The largest exponent of all the terms in the polynomial. So, in that last example, I wrote down 2x cubed plus 3x squared minus 6x minus 4. So, the degree of the polynomial, the largest exponent of all the terms in the polynomial, the largest exponent would be right here. That's 3. That's a degree of 3. This is 2. This is 1. This is actually x equals 0. Don't get fooled by that. Anything raised to the 0 power is 1, and we don't write 1. That's why it's supposedly x to the 0. Okay, so the largest one here is 3. So this is a degree 3 polynomial. You might want to write that down somewhere. Degree 3 polynomial. Standard polynomial form is in a standard form when all the terms are combined and the terms are written in descending order of the exponents. So what they're talking about is, you can see these are in order of degree and in descending order, meaning descending meaning 3 is the largest, so it's out front, and then 2, then 1, then 0. It doesn't matter. It's still in standard form. Say there isn't a second term, it's still in standard form because 3 is the largest, so it's out front, and then we go 1, 0 in descending order. So that's standard polynomial form. Just make sure you put them in order. Put the largest one out front. Okay? And then that goes to the next one, this leading coefficient. So leading coefficient, the coefficient of the first term. Or, I like to say it's the coefficient of the term with the largest degree. So I just find the term with the largest degree. So I'll write that example down. 2x cubed plus 3x squared minus 6x minus 4x to the 0. There you go, x to the 1. We don't ever write 1s, that's why you don't see that. They just simplify to 6x minus 4. It's just a fancier way to write it, making sure you understand that all of them have a degree there. But the largest degree we said was 3, so the coefficient out front is 2. So we would just say 2 equals leading coefficient. Okay. And there's another, Miss Johnson does a way better job explaining this than I can. But if you need her video, I can help you find it. That's not important. Flip it over, writing in standard form. So this is how I do this. We have the polynomial, 4x plus, this is a lot. 4x cubed plus 8 minus 3x plus 8 squared minus 12 plus 5x plus 3x squared minus 5x squared. I think I only screwed up once when I read that. Here's what I do. It says to write in standard form. So I come up here, I notice, okay, I notice I have this 4x cubed. So I might circle it, plus 3x cubed, okay. X cubed, that happens to be my largest term, or my highest degree polynomial. So my highest degree is 3, so I'm just going to add those. So I'm going to get 7x cubed. I'm going to do this all in different colors. So if 3 was my largest, I'm going to look for degree 2. Degree 2, I have, why is this doing this to me? I have a second degree there, and I have a second degree there. So 8 minus 5 is still going to be plus 3x squared. Now, I'm going to look for my 1 degree polynomials, or my 1 degree terms. I like terms better. 1 and minus 3 plus 5 is going to be plus 2x. Now let's switch to blue here. Plus 8 minus 12, that's just minus 4. So now I have this polynomial with degrees written in descending order, so I know that's the correct standard polynomial form. Okay, I combined all the like terms. The constant was just -4. So let's answer some of this. How many terms are there? I see 4 remaining terms. Alright, you can count them. 1, 2, 3, 4. What is the degree of the 4th term? So that's 1, 2, 3, 4. That's the last term here. Remember, that's like x to the 0. Now that looks like a 1. But the degree would be 0. So that's why we got to know that that is to the 0 term. Here, I'll put my little 1 here. X to the 0. List all the coefficients. So all the coefficients, and this is why you need to see this is a coefficient, this is a coefficient, and this is a coefficient. -4 is just a constant, because we don't have a variable written with it naturally. Naturally, we just leave it as -4. So list all the coefficients. So all the coefficients are 7, 3, 2. The constant is -4. I just told you that. Okay? And that's what you're doing for the rest of the back page. Alright? You're looking to identify these things. So let's just keep going on together. Write in standard form. Good thing I'm getting good at this. If I look at this, I have a degree of 3. Okay, that did not write where I wanted it to, but I'm not going to recalibrate the smartboard right now. So I have degree of 3. I have degree of 1, degree of 2, degree of 0, degree of 3, degree of 0, degree of 2. So 3 is my highest. So I'm going to take this 3x cubed out front, this 2x cubed. Usually I like to circle the plus in there, so I know that's what I'm doing. So 3x plus 2x is 5x cubed. Switch colors on you. Then I know that's the second one, so I'll get this plus sign here. Plus 2x squared. It's another 2. Yep, at the end here. Plus 5x. Plus 2 plus 5 is plus 7x squared. If you have different colors, use different colors. Whatever helps you keep track. I just have a degree of 1 there. It's -3x. I think that's my only one, so I'm going to write -3x. And then last but not least, the coefficients. I might square them sometimes. So that's a -12 is left there and a -6. So -12 and -6 combined is -18. So like the other one, how many terms are there? There's 4 again. What is the degree of the 4th term? It's actually a constant, so we know the degree is 0. List all the coefficients. So what is in front of the first variable? A 5. What's in front of the x squared? A 7. What's in front of the x? A -3. So those are my coefficients. What's the constant? -18. Just a lot of words and definitions, and you guys got to keep them straight. Ooh, this is a little out of order. Can I scroll this down? There you go. Write the following polynomial in simplified standard form. So, yeah, we just got to simplify it. Alright, so I see here I got my 3x cubed out front. So there's a 5 there. So I'm going to circle the ones to the cubed. Alright? Then these other ones are 0 and 1, so I'm not going to worry about it. But I have this plus 5x here. So my standard form, I know I got to write the largest one out front, so I'm doing 5x to the 5th. Then I have 3x cubed minus 2x. This is going to be minus x cubed. Now, notice I skipped x to the 4th because I don't see any. So now after x cubed, I'll look for all the x to the 2nd power or x squared, and I don't see any of those. So now I'm going to go down here, and I'm going to put a triangle, since I'm using all the same color here, above or around my degree 1 polynomial, or degree 1 terms. So I have minus 2x and minus 4x. That's minus 6x, and then I'll just underline or cross it out. Plus 4 plus 5 is plus 9. Okay, so if you have one color, maybe that's what I'd do, squares, circles, triangles, whatever makes you comfortable. So the degree of the polynomial, the largest degree we have is this 5 up here, so the degree is 5. Leading coefficient, just go back and find the largest degree. The largest degree was 5. Leading coefficient is 5. It's usually almost always out front for the degree and the leading coefficient. Unless they didn't ask you to write it in standard form, then you just got to go searching through it. So then this last one here. I'm liking red. Alright, I'm kind of paying attention this time. I see the x to the 5th right away. So I'm just going to write that, negative 2x to the 5th. Wow, this is awesomely calibrated. Apparently, smart boards aren't calibrated on Sundays. Okay, then I'll go back. I see this 4x cubed plus 5x cubed. And that's going to be 4 and 5 is 9x cubed. Now I'm going to do some triangles, I think. Triangle, triangle. Ooh, here's the one I can't forget. So I got 3 triangles here. But I'm not going to get confused by that. I always start with positive, so I would have went plus 4x. I'm going to go plus 4x minus 4x. They actually cancel out. We're at 0. And then I would still have this minus x here, so I just have 1. Minus x, and then I'd see minus 2 is what's left. Okay? Don't get confused by the x squares and the x to the 4th missing. That's not a requirement. They don't have to be there. Okay? So we just don't write them. We don't write x to the 0. We don't always write x to the 1. Okay, but those are things you should just pick up on. Shouldn't be too confusing that they're not there. So degree of the polynomial, what's the largest term here? Or degree with the largest term here? It's 5. Okay, it's right here. And then my leading coefficient goes with that. It's going to be negative 2. We're done. All right. It's more about the terms and making sure you guys have those down correctly. Thanks for your attention today. I think I heard a bunch of itchy and scratchy noises, so I apologize if they are in there.